Welcome to my channel, and here we are going to be working on the surface development of a complete cylinder. We are going to be working on the surface development of a complete cylinder, and for a cylinder and for prisms we use a method known as parallel line method. We use parallel line method for the surface development of prisms and cylinders. So this is the front elevation of the cylinder as you will be given in any exam where a question on the surface development of a cylinder is being given. Alright, so here we have the front view of the cylinder. So the diameter of the circular base of the cylinder is 50 millimeters, while the height is 70 millimeters. So this is all that we are given. So we now go and work on how we can produce the surface development of this cylinder. So let's start and see how it goes. So the first thing that we are going to do here is to draw a vertical center line. So you draw a vertical center line. You can start with horizontal center line if you like, there's no problem. So I'm not mandating it. That you start with a vertical center line. A vertical center line is drawn with thin long chain line. As you can see it here, you draw a long line, a dash, a long line, and a dash. Okay, so we draw horizontal center line like this. Alright, so the next thing that we are going to do is to draw the circular base of the cylinder. Alright, so we take a measurement of 25 millimeters on the ruler, 25 millimeters on the ruler. We take it from 4 to here. So this is 25 millimeters as we have here. So put a pinpoint here at this point, at the point of intersection of two center lines, then draw a circle like this. So draw a circle. Alright, so we are going to divide this circle into 12 equal parts. So I'll be using my set square to do that. So put the set square on the T-square like this. So draw a line. So draw a line through the center and set like this again. So draw a line through the center of the circle. Then so turn the set square like this. So draw a line like this, and then so to this side, so draw a line like this. Alright, so the next thing that we are going to do is to number the points on the circle. So I'll call this point, I'll call it point 0. This is point 1, this is point 2, this is point 3, here is point 4, this is point 5. Here is point 6, this is point 7, this is point 8, this is point 9, this is 10, and this is 11. You can number from 1 to 12, no problem. Alright, so the next thing that we are going to do now, having drawn the circular base, so you come up a bit and draw the horizontal line. Then with the set square, so come to this point 0 and draw a vertical line from this point 0 up. From point 111, they are the same the point on the circle, so draw a vertical line up. So from point 10, so 2 and 10, they are the same point on the circumference of the circle, draw a vertical line. And we have done that of 3 and 9, so for 4 and 8, so we draw a vertical line, and for 5 and 7 we draw a vertical line, and for 6 from this point we draw a vertical line. Now, so the next thing that we are going to do, we take a measurement of 70 millimeters, which is the height of the cylinder. So 70 millimeters, so just come up here and draw a horizontal line like this. Alright, so the next thing that we are going to do is to bring out the front elevation of the cylinder. So make this line a thick line. Okay, so make this line a thick line from here down, and then come to this side, draw this vertical line as a thick line from here to the base here. Then this base line, make it a thick line. Okay, and then here also we make this a thick line like this. Alright, so this is the front elevation of the cylinder as you see here on the screen. Now let's go for the surface development. So we are cutting it from this line, that is from this point 6. We are cutting it from there. So what we have to do now is to draw a horizontal line, come onto this base, and then draw a horizontal line to this side. Then come up here also, so draw horizontal line to this side. Alright, so we are cutting it from point 6. So what we have to do now, so move away a little bit from the given view and draw a vertical line here like this. Alright, so this point here is point 6. Alright, so the next thing that you are going to do is that you will calculate the circumference of this circular base. So the circumference of a circle is calculated with formula. Circumference is equal to pi d. So pi d, that is pi times what? Times the diameter of the circle, and this is equal to pi is 3.142. So 3.142. So times 50. The diameter of the circular base is 50 millimeters. So that will give us approximately 157 millimeters. 157 millimeters, approximately 157 millimeters. So you are going to take a measurement of 157 millimeters. So let me use my set square to take it. So my ruler is not as long as that. I will take it from 1. That means I'm going to, my 157 will stop at 16.7. So this is 16.7, which is equal to 157 millimeters. So at this point, so we have taken the measurement of 157 millimeters from this point to this point, which is, this distance is equal to the circumference of this circle as we have calculated it here. So this point is also 0.6, because when we go around like this, we come back to this 0.6. Okay, so now, so we are going to divide this distance into 12 equal parts, as we divided this circle into 12 equal parts. So I'm going to do it and you'll see it. So just set your set square like this, set square like this. Okay, or you can use a ruler if you like. So draw a line in this direction. Alright, so I'm going to be taking a measurement of from this point. So I will take 1 centimeter, that is 10 millimeters each. This is 1, there is 2, this is 3, this is 4. I'm not taking it from 0. Okay, I took it from 1. This is what? This is 5, here is 6, this is 7, here is 8, 9, so this is 10, 11, this is 12. Okay, alright, so what we have to do now is that we join the last one with 0.6. Okay, so join like this. Then with the set square, so I will do it, we all see it. So with the set square being set like this along this line, so the line is bent like this, just set like this. So we are dividing a line into a number of equal parts, which I believe you know. So set the set square like this, and then so move it to the next point. So while you hold it together with the ruler, draw this line. Okay, then move to the next point and draw the line. So move it to the next point and draw this line. So move it to the next point and draw. So to the next point and draw. So take it to the next point and draw. So the ruler must not shift. Okay, so the next point and draw. So only the set square that we are moving to next point. So draw the line. So next point, draw the line. Next point, so draw the line. And lastly, draw the line. Alright, so we are going to number this. So after 6 we have 5. So this point is 0.5. Then we have 4. This is 0.4. Okay. Then we have what? We have 2. So we have 3. Then we have what? We have 2. Followed by 1. Then we have what? We have 0. Then here we have what? We have 11. Then we have what? We have 10. So we have 9. As we are moving like this, so we have 8. Then we have what? We have 7. So this is it. Alright, so on each of these points we are going to erect a vertical line. So after 7, so we get back to 6. So we are going to erect a vertical line on each of these points with 18 continuous line. So I usually use my red pen for 18 continuous line. So draw a vertical line here. At this point 7, draw a vertical line. At point 8, draw a vertical line. At point 9 here, draw a vertical line. Okay, so at 10, draw a vertical line. At 11, draw a vertical line. At 10, so draw a vertical line. At 1, draw a vertical line. And also at 2, draw a vertical line. At 3, draw a vertical line. At 4, draw a vertical line. And at 5, lastly, so draw a vertical line. So we have this. Alright, so this is a complete what? A complete cylinder. So what we have to do now is that, so make this line a thick line. Make this line a thick line from here. From here to this end. Alright, so then we also make this line a thick line. So from here to this end. Okay. Alright, so and then so this line at 6 we make it a thick line. And this line here also at 6 we make it a thick line. So this is the surface development of a complete cylinder. It's as simple as I've done it here. So thank you and keep on practicing. God bless you.